Hi, this is Mr. Lonergan, and I'm here to talk to you about the SAT strategy of plugging in. Plugging in is where we take all of the variables, things like x, y, and z, in a problem and replace them with actual numbers. It turns algebra problems into simple arithmetic problems. Here's an example. Claire is C years old and is 6 years younger than Alan. In terms of C, how many years old will Alan be in 3 years? Yikes, lots of confusing language. I know this is a good candidate for a plug-in problem because I see variables in the question and variables in the answer. So the first thing I'm going to do is substitute a number in for the variable. Whenever I'm talking about age, some people are younger, some people are older, so I'm just going to choose a number that's easy for me to remember. I'm going to say Claire is 10 years old right now. So my variable is going to be C. But that's not what I'm trying to answer. So let me replace this now. Claire is 10 years old and is 6 years younger than Alan. If she's 10 and is 6 years younger than Alan, what does that mean about Alan? Alan has to be 16. In terms of C, how many years old will Alan be in 3 years? In 3 years, well, if Alan is 16 now, Alan will be 19. So my target answer that I'm trying to answer is 19. And since that's my target, I'm going to put 2 circles around that number because that's the number I'm looking for in my answer choices. I plugged in 10, but the answer I'm looking for is going to be 19. So just to fill in my chart before I answer, my variable was C. My target question was Alan's age in 3 years. I chose a value to plug in for the variable. I chose C equals 10. And then my target answer that I'm going to be looking for is 19. So now let's look at our answer choices. If you haven't done it already, I'm still going to remember that I said C was 10. So I'm going to say which one of these gives me an answer of 19. 10 minus 6? No. 10 minus 3? Nope. 10 plus 3? Nuh-uh. 10 plus 5? No dice. My last best choice, 10 plus 9 equals 19. That's the only one that hits my target. So the answer is E. Let's try one more. This one's talking about Sinead. Sinead has 4 more than 3 times the number of hats that Maria has. If Maria has X hats, then in terms of X, how many hats does Sinead have? Well, let's start by figuring out what we want to plug in. X is a number of hats. I don't know how many hats you have. I want to choose a number that's not too big, not too small, and a number that's easy to work with. When I say easy to work with, I usually mean numbers like 1 or 2 or 5 or 10 or 100 that are easy for me to do multiplication in my head. In this case, I'm going to go ahead and say X equals 5. Maria has 5 hats. Let me go back and rewrite the question. Sinead has 4 more hats than 3 times the number of hats that Maria has. 3 times the number of hats Maria has, that's now 3 times 5. Sinead has 4 more than 3 times 5. In other words, if I talk about 3 times 5, I'm talking about 15. Sinead has 4 more than 15 hats. 4 more than 15, now that means if I include the 4 more than, I'm talking about 19 hats. What a coincidence. 19 was what I was talking about last time, and now I'm talking about it again. So, when I let X equal 15, I found out that Sinead has 19 hats. Once again, that's my target. Now I'm going to go back and plug in x equals 5 and find out which one of these tells me the target answer of 19. Starting at the beginning, 3 times 5 plus 4. 3 times 5, 15 plus 4. Bingo! That's 19. I look quickly at some of the others and see that none of the others match up. You can pause the video and double check me if you don't believe it. But the best right answer for this one is the first one, 3x plus 4, because it matches my target. When x equals 5, 3x plus 4 equals 19. Good luck!